This is a continuation of the second part of the video series where we wanted to finish entering data for conductors and maybe some motor control centers and things. So I'm going to left mouse double click on this conductor. It brings up a dialog box, and this is the typical information that we need to see from a conductor. We need to know how many per phase conductors there are. So if I put a 3 in here, that means there's 3 on A phase, 3 on B phase, and 3 on C phase, 1 conductor cables. Now if I make this a 3 conductor, that means this is a 3 conductor, so there'd be 3 conductor on A, B, and C. Interlocked armor aluminum, interlocked armor steel, messenger aerial. If you don't know the standard terminology, no problem, just hit the help command and we'll explain it to you. And that goes for any dialog box. Insulation types, we model the XH series or the cross-linked polyethylenes, the thermoplastics, the THs, the heat-resistant rubbers or RHs, even the old paper insulated lead conductors if you've got a really old facility. Any size from 2000 kcmil to 14 AWG. Any length, we'll just put in say 125 feet. All you need to do is walk off that distance in 3-foot steps, account for up, over, and down, and you'll be within 5%. We model direct buried, in conduit, tray, or air. And we model whether it's magnetic in steel or one of the non-magnetic types. And then all you have to do is hit calculate, and we'll determine from the proper algorithms the exact conductor impedances. Now, we can get really fancy if you want to go into specifications, and we can model different duct banks and tray derating, whether the conductor is flat, triangular, or right triangular, what the conductor spacing is, and any field temperatures and things. You typically do not need to do that for most studies. You can also model the ground wires, the neutral wires, and whether or not we're modeling harmonics and things. Typically, all you need is this first page for most studies. Now, a lot of people like to morph the graphics so that we can actually say, okay, everything in a dash line is conduit or in a tray or something like that. And then what we would do is we would right mouse click, copy, left mouse click, press slide release, right mouse click, paste, and there are all our conductors. Now, another thing we might want to look at is when we're modeling a system, we're going to add a couple things to the one line. So when we did the wizard, it actually added all motor control centers. I'm going to left mouse click, press slide release, standard Windows highlighting command, hit the delete button, say yes to that, and I'm going to come over here and grab a panel, and we'll snap on a panel. So now you can see we've got these conductors going down to a panel. Now both panels and MCCs are also buses, because you'll see these branches terminate on this 800 or 1200 amp MCC bus, or this 225 amp or 400 amp panel, whatever size it is. So what that means is we can actually grab a conductor, and so we can attach other panels or daisy chain other panels or transformers to these MCCs and panels. We'll grab another MCC and snap it in another panel, and we can actually daisy chain these units, and then we can actually left mouse double click on this MCC, go to the description tab. Let's say we want about 10 buckets, and I can go to section space 3A, whatever it is, and say I want this to be MCC-7, and instead of a motor load we change that to a sub MCC. Then that allows us to pick a subline, so that's conductor 8, to MCC7. So here's our MCC7. So we're picking the bucket that this conductor is going to come out and daisy chain to this MCC. Now what I'm going to do is I'm going to tab over. There's about 80 cells, so if you're doing an asset management system, this is really an unbelievable tool where you can enter all the different types of data for this MCC bucket. And I'm going to tab over, and I do that by sliding. I can go to the motor spec data, so you can see all these red cells. If these were motors, I would need to enter the red data, the horsepower and the X/R ratio, or the protective device data. So you can see that here is the little data button for MCC7. So I can actually say press this button, and it will allow me to pick, say, a General Electric K1200 frame THKM8 breaker. It tells me it's thermomagnetic. It's rated for 35 kiloamps, and I've got a phase trip setting of, say, 800 amps and an instantaneous of 8,000. So now when I say OK, it fills out all that data in my unit, so I know my conductor information, I know my breakers and everything. And so when I say OK, now that 800 amp breaker feeds this conductor down to this MCC. So when I go to do my arc flash calculations or my protective device time current curves, everything is modeled in explicit detail. All the time current curves will come up, all the proper trip times, all the proper arc flash hazard calculations. It's very, very simple. Same thing applies to panels and those daisy chains. Okay, so you can see how easy it is to create this system. And once you have your data entry, what you want to do is you want to do these in blocks. I'll do one substation, and then I'll highlight that substation, right mouse click copy, right mouse click paste, drag the system over. Now I have an identical substation. I can just snap it into my breaker, and I have less than 25% of the data entry work that I have to do for this substation. What I typically do then is I highlight this in a color. So I'll go to my color palette, I'll pick a color. That color tells me those are copied values, and all I have to do now is go make my changes. So once I go to my transformer, I'll double click on it. I'll change that to maybe a 2000 kVA. My impedance maybe changes to 6%. And once I do that, I'm OK. I highlight it, come back to my color, change back to automatic, and that tells me that that data has all been updated. So it's very, very simple and easy to use as far as creating a one-line.